My name is Jermaine Lindsay, and this is my Group 8 spectroscopy. Well, it's my spectral problem. Let me focus my camera. Oh, my spectral problems for the University of New England, Chemistry 1020. So, what I have here is the compound of C10H12O. And with that, the first thing I did was draw. So, I drew it to the best of my abilities, and either this is the triplet or that's the triplet. I can't remember which, but those kind of mix me up depending on where they're at, especially once the double bond is involved. But I was able to write one of those here as well, kind of switched it up. But to discover what this compound was, I went to the highest one first, which is going to be the sp3 in the IR spectrum, because that peak is right around 3,000. I've seen anywhere between like 28 to 31 typically, and the hydroxide group is the only one that I know is a little bit higher, but there was no peak there, so I said that this probably had to be that. With this being a little bit too high, with around 1700, I said this is one of these was going to be that double bonded either aldehyde or ketone group. I believe it's an aldehyde because that carbon is bonded to another carbon, and then which would be the R group, and then the double bonded C, which is right around 16-ish, was going to be that double bonded carbon to carbon, and then right here around like 13 is where I've seen it typically is going to be that single bonded carbon to carbon. So the aromatic ring also comes into play when we talk about the double bonds, but not specifically on this one, but this one. So the 13C is probably my favorite because what I did was, okay, I was able to identify the carbonyl group pretty easily, which is either the aldehyde or the ketone. And the aromatic ring says 120 to 140, and there's 3 hits in that range. So I was thinking, okay, since I have that, that's going to leave me my 1, 2, and my 3. So that was there. And that kind of led me to believe, okay, I'm in the right direction. This one was a little bit trickier, so I got my carbon-to-carbon bonds here, and I forgot to put here these would be my carbon and hydrogen bonds. Okay, which would be around 40 on my 13C. So the substituted benzenes is pretty much going to be where that range comes from. It's not really substituted. I mean, they're all carbons. So for example, like if like a nitrogen was here, like an oxygen was there, but it's for the simple fact that they were all grouped together and there's only one oxygen, kind of safe to put it right there. Then when I move towards the back, this confused me a little bit, but I know that from the aromatic rings, you're going to have a little bit higher because those hydrogens are going to be closer together. The bond angle is going to be a little bit closer. So anywhere from between 8.5 to 6.5 is kind of what I got through right here. And for the hybridizations, I used, well, not hybridizations, but for the N+1s when figuring out the protons and where they were going to be as far as the multiplicity. There it is. Sorry. So for the multiplicities, it was going to be 2H here, so there's 2 protons, 3 protons, which gives me 5, 2 more, which gives me 7, 2 more, which gives me 9, and 3 more, which gives me 12. So that's going to match up the total of protons. Then this 2H being that sextet, which is going to be counting the peaks here and doing the N plus rule. I've seen somewhere it was N-1, and I think that's what kind of confused me. And I tried to stick to just what the hydrogen number was. But the 1H is a little bit harder for me to read, not as far as the spikes, but as far as like trying to figure out where the multiplicities go. But I think from looking at everything, that multiplet I'm pretty sure was a pentet because I ended up just counting the peaks. So each peak is going to get 1, 2, 3, 4, 5. This one gives me 3, I think. 1, 2, and then this one right next to it. So I went with that to give me double it on that one. I ended up putting a pentet for that one, I think, on the next page. Triplet there, and a sextet there. Now, all the corresponding numbers are going to be at the 1, around 1.7, around 2.93-ish, and this one is going to start around like the 7.3, 7.4, and then go all the way up to like 8.1, 8.2. Once I got there, I also redrew my structure. And to determine the DU, I was able to determine that I had the 10 hydrogens. I'm sorry, the 12 hydrogens, the 10 carbons, and I was able to do 2 times 10, which gave me my 20. Subtract that from my 12, which is going to be 22. Sorry, I didn't. I just realized that. Yeah, I didn't. I kind of do math in my head, so that should be 22 minus 12. And 10 over 2, give me your 5. And so for the frequencies at 3000, as I mentioned earlier, which is going to be the CHEM hybridization, which is going to be pretty much the biggest that we do have on the graph, which is going to be right there. Followed up by the C to O carbonyl group next to it, and then the C to C. So around 1700, my CO, and then CC almost spot on at 12. It's actually pretty closer to 13, I think. So I didn't change it, but it's closer to 13. Let me focus here. So I did end up putting aldehyde there because that's what I thought was going to be most effective, like descriptive, because of the extra carbon it was bonded to. 120 to 140 is the aromatic carbon, so this is going to be my 13C. So right there, my aldehyde up at the 200s. 120 to 140 is going to be my aromatic ring, my C to H bond, and my C to Cs. Then we come down to the chemical shift. So for the 1H, it was, again, a little trickier, but I was able to get my 1 here. 3H integration, multiplicity of a triplet, which is that methyl group. So that's going to be the one that I kind of wrote on the front part of this page. Oh, that I got. And I kind of just wrote triplet as I was going through it. But that one right there is going to symbolize that one right there, triplet all the way up. Then that 1.5 to that 2, that 2H, that sextet, it's going to correspond right there. My phone's acting out to that one. And then so on and so forth. So that 3-2H triplet, 3-2H triplet is going to correspond to the bond between the O, CH2 right there. And then that one. Then my methyl group right there. Then my CS3, CH2, CH2, which is going to be, I think, coming off of this one. Then I got 7.5 and the 8, which is going to be the pentet, which is right in the aromatic ring. So it's going to be right before we head out, right there. And then that 8 is also going to be in the aromatic ring. The doublet, I think that's the one in this corner. I could be wrong, but that's what I ended up getting for my chemical shifts for the 1H. So 1 all the way up to 8, which is going to correspond with the bonds for the methyl group being the lowest, aromatic ring being the highest due to the amount of hydrogens being around it, are going to be a lot larger and wider in number. I was able to get this for my 1H, flip it over, got that for my IR, and I got this for my 13C, and that's what I devised as C10H12O. And hope it's correct. I need it to be correct, but I think I did all right.